Many people assume that aging is simply part of life. Wrinkles, declining vision, memory problems, heart disease, all of it is often seen as an unavoidable consequence of getting older. But when scientists look at aging through the lens of biology, the picture becomes far more complex. Today we are going to talk about one of the most fascinating discoveries in modern medicine: the fact that the immune system of men and women does not age in the same way. Not only do male and female immune systems age at different rates, they follow entirely different biological pathways. And these differences influence far more than most people realize. They affect how we respond to infections, how well vaccines work, how much inflammation develops throughout life, the risk of autoimmune disease, the risk of cancer, and possibly even how long we live. Today I will show you exactly how this happens, from individual immune cells all the way to real-world clinical outcomes. Let us start with a simple question. Why do some people recover from infections quickly while others become seriously ill? Why does one person receive a vaccine and barely notice it, while another develops fever, fatigue, and muscle aches for several days? Why are autoimmune diseases much more common in women, while certain cancers occur more frequently in men? The answer lies in a process known as immunosenescence, the aging of the immune system. But immunosenescence is not simply a gradual weakening of immunity. That is one of the biggest misconceptions. The immune system does not merely become weaker with age. It reorganizes itself. Its architecture changes. The balance between immune cell populations shifts. Inflammatory signaling changes. The way immune cells communicate changes. The way the body reacts to threats changes. It is almost as if an army does not shrink in size, but instead completely changes its strategy for fighting wars. And this is where things become particularly interesting. Because there is not one universal aging pattern. There are two. At some point in life, usually somewhere between the ages of 40 and 50, the immune systems of men and women begin moving down different biological paths. To understand why, we need to zoom in to the cellular level. As women age, the number of cytotoxic T cells tends to increase. These are the immune system's specialized killer cells that identify and destroy virus-infected cells and damaged cells. At the same time, the activity of natural killer cells and certain inflammatory monocyte populations also increases. The result is an immune system that remains highly alert, highly reactive, fast to respond, and often very effective at fighting infections. But this advantage comes with a cost, because alongside this heightened immune activity, there is also an increase in chronic low-grade inflammation. Scientists often refer to this phenomenon as inflammaging. It is a state in which the immune system remains partially activated even when no immediate threat exists. The body behaves as though it is constantly preparing for battle. This chronic inflammatory state is believed to be one of the key biological reasons why autoimmune diseases are significantly more common in women. An immune system that becomes exceptionally good at identifying threats can sometimes become too aggressive, and when that happens, it may begin targeting the body's own tissues. Instead of distinguishing perfectly between self and non-self, it starts making mistakes. The result can be autoimmune disorders in which the immune system attacks joints, nerves, connective tissue, the thyroid gland, the intestines, or other organs. Now let us look at the male aging pattern. In men, immune aging tends to follow a different route. There is generally less of this dramatic inflammatory activation. The changes are often quieter and more gradual. However, another phenomenon begins to emerge. As men age, there is an accumulation of certain populations of naive B cells. These are immune cells that have not yet encountered specific threats and therefore have not been fully trained by previous immune experiences. At first glance, this may not seem particularly important, but research suggests that aging men experience an increase in a specific subgroup known as CD5 plus B cells. And this is where the story becomes much more significant. Increased numbers of these cells have been associated with conditions such as monoclonal B-cell lymphocytosis, which is considered a potential precursor state for chronic lymphocytic leukemia. In other words, while the female immune system tends toward excessive activation and inflammatory errors, the male immune system may be more vulnerable to the gradual accumulation of cellular abnormalities that can contribute to malignancy. And this highlights one of the most fundamental differences between male and female immune aging. The female immune system is active, reactive, inflammation-prone, exceptionally vigilant, but also more susceptible to autoimmune mistakes. The male immune system is generally more restrained, less reactive, less inflammatory, but potentially more vulnerable to the accumulation of abnormal cells that can eventually contribute to cancer development. So why do these differences exist? Scientists currently point to three major factors. The first is hormones. Estrogen has a powerful stimulatory effect on the immune system. It makes immune cells more responsive, more active, more sensitive to signals, more prepared to launch a defense. This is one reason why women, particularly during their reproductive years, often generate stronger immune responses than men. Testosterone tends to have the opposite effect. It acts more like a brake on immune activity. It dampens certain immune responses and reduces overall reactivity. This helps explain why men often generate weaker responses to some vaccines and may be more susceptible to certain infections. Neither approach is inherently better. They are simply different evolutionary strategies. The second factor is genetics. Many genes involved in immune regulation are located on the capital X chromosome. Women have two capital X chromosomes. Men have one. Although one capital X chromosome in women is partially inactivated, the process is not complete. As a result, women often have higher expression of certain immune-related genes. This includes genes involved in detecting viruses and activating immune defenses. That increased genetic activity may contribute to stronger immune protection, but it may also increase the likelihood of excessive immune activation. The third factor is the microbiome. Trillions of microorganisms living in the gut communicate continuously with the immune system. They help regulate inflammation. They influence immune development. They shape how immune cells respond to threats. And importantly, the composition of the microbiome differs between men and women. Hormones, diet, metabolism, and lifestyle all influence these microbial communities. As a result, the microbiome adds another layer of biological differences that further amplify the divergence between male and female immune aging. Now let us see how all of this appears in everyday clinical practice. Imagine two patients who are roughly the same age, both around 60 years old. Both receive a seasonal influenza vaccine. The woman returns the next day complaining of fever, fatigue, muscle aches, and general discomfort. She feels miserable for a day or two. Then she recovers completely. The man experiences virtually no symptoms, no fever, no fatigue, no significant reaction. At first glance, it might seem that the man had the better outcome. But immunologically, the situation may be very different. The woman's symptoms often reflect a stronger immune response. Her immune system recognized the vaccine aggressively and produced a robust antibody response. The side effects were unpleasant, but they were also a sign of strong immune activation. The man's immune response may have been milder, and in some cases, his resulting immune protection may also be somewhat weaker. This is a classic example of how sex-based immune differences manifest in real life. Now let us turn to large-scale research data. Recent studies examining more than 1 million immune cells from individuals ranging from 19 to 97 years of age have revealed something remarkable. Approximately 25% of age-related immune changes occur similarly in both sexes, but the remaining changes differ substantially. Researchers found that women exhibit more than twice as many age-related changes in gene activity compared with men. This suggests that female immune aging involves a much more extensive biological remodeling process. Interestingly, the most pronounced changes tend to occur around the age of 70 in women and somewhat later in men. There is another important observation involving autoimmune-related genes. The activity of these genes tends to increase with age in everyone. However, women over the age of 50 show significantly higher levels of expression. This is consistent with the increased risk of autoimmune conditions such as rheumatoid arthritis, multiple sclerosis, and inflammatory bowel disease. So let us summarize what we know so far. Immunosenescence is not simply the gradual loss of immune function. It is a strategic transformation. a complete reorganization of how the immune system operates. In women, the dominant pattern is one of maximum protection, accompanied by a higher risk of chronic inflammation and autoimmune disease. In men, the dominant pattern is one of greater restraint, accompanied by a higher risk of cellular errors accumulating over time. And this realization is beginning to reshape modern medicine. For decades, medicine largely followed a universal model. The same treatment approaches, the same dosing strategies, the same preventive recommendations, the same vaccination protocols. But biology is telling us that one-size-fits-all medicine may not be enough. If male and female immune systems age differently, then perhaps they should not always be treated identically. This shift is already underway. Modern medicine is increasingly moving toward personalized care, a future in which treatment decisions are based not only on age and diagnosis, but also on sex, genetics, immune profile, and individual biology. This could eventually mean different vaccine strategies, different preventive interventions, different drug dosing recommendations, different approaches to reducing inflammation. For example, some evidence suggests that women may achieve equivalent vaccine protection with lower doses because of their stronger immune responses. Men, on the other hand, may benefit from strategies that provide additional immune stimulation. And this is likely only the beginning, because the implications extend far beyond infections. The immune system influences cardiovascular disease, neurodegeneration, cancer, metabolic disorders, and many other aspects of aging. It is deeply connected to virtually every organ system in the body. So if immune aging follows different pathways in men and women, then aging itself may also follow different biological trajectories. And that brings us to a profound question. Are we ready to fully accept that medicine may need to become fundamentally different for men and women? Not simply at the level of symptoms, not simply at the level of diagnosis, but at the level of core biology itself. Because the differences are no longer theoretical. They have been measured, observed, quantified, at the level of genes, immune cells, inflammatory pathways, and clinical outcomes. Ignoring those differences may mean missing enormous opportunities for more precise and more effective healthcare. Perhaps the future of medicine will not be built around universal protocols. Perhaps it will be built around understanding each individual person, their sex, their age, their genetics, their immune system, their unique biology, and understanding how the immune system ages may be one of the most important keys to that future. So the next time you hear someone say that the immune system simply gets weaker with age, remember that this is only part of the story. In reality, the immune system changes. It adapts. It reorganizes itself. And it does so differently depending on whether you are a man or a woman. And that may be one of the most important and most overlooked discoveries in modern medicine.